Hello there, I am Dr. C.N. Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis of business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Hello everyone, thank you for joining me on this channel once again. If you're new to this channel, you're very much welcome. This is where we intend to help students all over the world to demystify their fears as relates to business mathematics, business statistics, and other related subjects. Today, we are going to look at a very important area of statistics, which is regression analysis. I'm going to be doing an intro in this video, and in the videos that will be following after, we'll be looking at some of the very vital examples that you can use to harp on what you're going to learn from this video. Now, regression analysis is closely related to correlation, coefficient correlation analysis, but they are different. Whereas correlation estimates the relationship and direction of relationship, the strength of relationship, and the direction of relationship between two variables, regression, on the other hand, predicts or shows how much one variable affects the other. And we're going to be looking at two variables, x and y, how x affects y, or how y affects x on the other side. I have some notes on the board, and which I'm going to be reading through and explaining line by line. I would want you to make these notes yours by having your pen and paper to copy these notes so that you can read them again on your own, or better still, you can still watch the video again and again. So as I said, in this video, we are going to look at an intro, and we're going to look at how we have with the relationship that will exist between x and y, and how x affects y, and how y affects x. And that's the whole idea of regression analysis. Please come on board and let's look at what we have. Please, you can zoom closer so that our viewers can look at what we have. From a basic definition of regression analysis, as you can see on the board here, that regression analysis estimates or predicts the value of one variable given the value of another variable. That's to say, you do not know what one variable is, but you're given another one. So one variable you're given, now based on what that variable you're given, you now predict what the other will be. So the variable that is predicted based on another is called the dependent variable, because it's dependent on what the other value is. Also, the variable that predicts is called the independent variable. The independent variable can assume several values, different things. So when you now impute that independent variable, any value you impute in the independent variable will give you the value of the dependent variable. Now, in a linear relationship, we have two variables given as this, where we have y out here and x in here. In this case, the x is the dependent variable because it is dependent on whatever the value of x is. For example, let's look at an example of y equals to 5 plus 2x. Let's give an example of y plus 2x. 5 here is a constant or a fixed value that doesn't change. 2 is the slope or the rate of change, and x here is what we want to assume whatever it is. Now, when we have 1 as if x here was 0, 0 times 2 will give us 0, and 0 plus 5 will give us 5. So 5, y becomes 5. If x is 1, 2 times 1 will give us 2. 2 plus 5 will give us 7. So y becomes 7. If x becomes 3, 3 times 2 is 6. 6 plus 5 is 11. So y becomes 11. So whatever value x assumes here as the independent variable that can change, it will predict the value of y. That's what we mean by the relation between y and x here. So x is the independent variable and y is the dependent variable in this scenario. Now, as x changes, as we have seen here, as x changes, the dependent variable y also changes. Now, when the two values of x and y are plotted on a graph, the two straight lines of best fit pass through the plotted points. These lines are known as regression lines. Those lines on a graph given like this, and then by the time all the values are plotted on the graph, you have the one you join some on this side and you join another one on this side, just like that. These lines that are drawn are called regression lines, drawn on the plotted point. Now, these lines are also based on two equations. These equations are called regression equation. Just as I said earlier, please, I would like to copy these things in your notebook. So these lines are based on two equations known as regression equations. These equations estimate one value for a known value of the other. So you may know x and you do not know y. So based on your knowledge of x, you can predict what y is. On the reverse, you might have the value of y and you don't know x. So if you have the value of y, you can predict what x will be. So that's what we mean by that. Now, based on what I've just said, now these values estimate one variable for a known value of the other. The regression equation of y based on x, this is y on x, the regression equation of y, that finding or predicting y, that's what we mean by regression. Remember, regression predicts a value based on the knowledge or known value of the other. So the regression equation of y, predicting y based on x, this is written, y on x is given as what we have. This is similar to what we have up here. Can you see that? This is y equals to a plus b x bx. So I'll just put 1 here because we're going to have another equation which is different. So we're looking at y is the independent variable, dependent variable here based on x. So we have y on x, y will be outside and x will be in here. So based on the value of x, we can predict y. Now, in a reverse, we can have the regression equation of x, predicting x based on y. We have the value of y is going to be the reverse, so that we have x out here plus a, the constant, and b, the slope, the rate of change, and then y is predicting x. So this is what we call the regression equation. But then we're looking at a scenario where we may be given a distribution. We'll be given the distribution, and then we want to find what y is and what x is. We want to predict. We're given a distribution of x and y, and we want to predict. Let's say you're told that the relationship between x and y, you're giving values for x and y to a particular time, and then you want to predict what it will be in the future. You want to predict what will be in the 10th week. You want to predict what it will be in the 10th month. You want to predict what it will be in the sixth month. So you're given first month, second month, third month. What will it be in the next month? So you want to predict what it will be. Now, in that scenario, let's go to the other side of the board to see the regression equation that we have to be dealing with. Let's come over here. Here we're saying that in a given distribution of x and y, the regression equation of y, that is predicting y based on x, is given as y is equal to the mean of y plus your beta, which is your rate, your slope, y based on x, and you have x minus x bar. These things we are going to look at in the next video that we're going to have. We're going to look at an example of how we can apply these first parts of our regression equation. We're going to look at how we're going to apply this first part. And in subsequent video also, we are going to look at sometimes you may be given the mean and standard deviation of, your distribution. You're not given the distribution, but the mean has already been determined. The standard deviation has already been determined. Now you want to predict what y will be. This is the formula we're going to use. So this will be y equals to the mean of y plus correlation coefficient as you'll be given, and the standard deviation of y over the standard deviation of x, and you have x minus x bar. This is where our regression, remember regression? R is correlation coefficient, where R is the correlation coefficient. So also the regression equation for x, that is predicting x based on y, is given as just the reverse. In this case, we are given our distribution. So based on our distribution, we have to find the value of x, we have to find the value of the mean of x and the mean of y. From what we derive from the distribution, we have a table and we can find and predict the value of x and y. I want to assume that so far what I'm saying this far may not be very practical to you, but I want to encourage you to watch the next video that we're going to have from this one, so that you can see how we can apply these equations. We can apply these equations to determining or predicting the value of x and y. So welcome to our lecture series on regression. Remember, regression predicts values in the future, unknown values, based on the value that you have on one variable. Based on the value you have on one variable, you can predict what the other value will be. That is a function of regression. So look at what we have on the board, make your notes, and prepare for the next video that we are going to have with you. God bless you.